Now we'll go to B3, which is carbohydrates. Probably the most difficult section in option B. You are required in B3.1 to know the features of carbohydrates. Those are the chemical features that make them recognizable. They contain at least one carbonyl group, or carbonyl group as I've heard it called, which is fine. At least 2 hydroxyl groups, and they have the empirical formula CH2O. So one thing about carbohydrates, which is most important, or most difficult, excuse me, has to do with bullet point 2 of this section. It discusses straight chain form versus ring structure. So I'm going to do the best I can here. This is a fairly advanced topic, so I'm going to do the best I can. So we're going to focus on glucose. Glucose is a family of compounds called hexoses, 6 carbons long, and the straight chain form looks like this. At the beginning of that chain, we'll call that carbon number 1 as an aldehyde group, and we usually draw the carbons, these 6 carbons, straight down. Okay, carbon 1, 2, 3, 4, 5, 6. Okay, now each of these carbons from numbers 2 through 4, actually number 6 as well, but it's most important for 2 through 4, they have these hydroxyl groups coming off in various directions. For glucose, it's to the right, to the left, to the right, to the right. Now down here, this last one is 2 carbons and an OH group. On the other side here is just hydrogens. Now this is important because, I'm going to do the best I can here, this compound will form 2 different ring structures. Now it does so by something called mutarotation, which is actually not really necessary for me to teach you what it means, but I guess I can give you a hint here, or a reminder, that if we were to draw this more accurately, remember, it would not be a straight line, that each of these bonds has a certain angle. If we remember the Vesper theory, this angle, for example, is 109.5, or very close to it. So the structure is a little more crooked, I guess is the best way of saying it. In addition, this bond right here that I'm drawing can rotate, just as any single bond can. So imagine this bond were spinning. Now, when this ring shape forms, what is going to occur is this carbon number 1, is going to bond with that oxygen right there from carbon number 5. So carbon number 1 and carbon number 5, think of it as bending and then straightening back out, bending and straightening back out. It's not really important how it happens. So when it does so, here's how we translate this structure. That oxygen right there is the oxygen that's involved right here. You don't really need to know that, but it is going to help us make sense of this. That's carbon number 1, 2, 3, 4, 5, and then number 6 is up here, and 6 didn't really get changed. So there's the ring shape. This oxygen is that oxygen. Okay, now it's important to understand right here. Now, this carbon, this bond specifically, can spin. So when it attaches here, it may be in this arrangement, or it could have been the double bond in the other direction. So depending on where it was when it bonded here, that would place this oxygen, that oxygen, which is going to come off this carbon. It'll either come off of it in the upward direction, or if we do the other one down here, it will come off in the downward direction. So there's an important distinction to make between those two compounds. When the hydroxyl group here, which was this oxygen, when it is in the upward direction, we call that a beta arrangement. That's beta glucose and when it's downward we call that alpha glucose. Most common in our body is alpha glucose, also called alpha D glucose. For those of you who care, the D stands for dextrorotatory, which means to the right. It's referring to carbon number 5, this hydroxyl group to the right. L-glucose would be an exact mirror image of this compound. This OH would be here, this one there, that one there. So you don't need to know that, just felt like teaching. So it's important to understand that this one was unaffected. That's where we get the downward here. This one is up. This one is down. And this one has an H group right there. Please understand that O right there was that one. There's no up or down OH group here. So this is the characteristic structure of alpha glucose. This is beta glucose. Sorry. These are the same. I'll just draw the OHs in this side. So that characteristic down, up, down, at carbons 2, 3, and 4. Remember, up hydroxyl is beta, down hydroxyl is alpha. So this process can actually flip-flop back and forth. There is a preferable structure. It's not important which that is or why. Just understand that they are both possible, and the alpha or beta nomenclature refers to around carbon number 1. So you are required to know that. There is also the same thing can happen with a compound called fructose. If you really want to look that up, I'll let you, but I would bet my money that this is the one you're going to see. Now, these monosaccharides like glucose can connect to each other in what are called polymers. You can form groups of 2, which are called disaccharides. If one is called a monosaccharide, then 2 is di. And like all compounds in a biological system, when they connect together, they will do so in a condensation reaction. So you are required to know 3 disaccharides. Their names are lactose, maltose, and sucrose. Now, I'll let you look up to what they're made of. Just understand that they are 2 monosaccharides similar to glucose. I believe, and I'm doing this from memory, so it's been a while, I believe that lactose is galactose and glucose connected. I'm not sure about maltose. I've actually, gosh, that one escapes me. Sucrose is glucose and fructose connected to fructose. So you can look those up to what the specific combination is. It's not important that I show you that here, because in the next little sequence here I want to talk about polysaccharides. These are important. Poly meaning many. Remember, di is just 2. Well, in polysaccharides, there are many of them stuck together, and there are some important ones that I need to point out to you. So first of all, talk about plants. There is starch in plants, and there is cellulose. Now this is a pretty important distinction. Starch is a polymer, meaning many chains. Now I'm going to do my best here. I'm going to draw glucose in an abbreviated form. This is going to be alpha glucose. So just to remind yourself, if you look up here, alpha has the hydroxyl group downward. So I'll draw the OHs down, up, down. Remember, we got our carbon H group here. So starch is a polymer where there are many alpha glucoses. And this time I'm going to abbreviate. There are many alpha glucoses connected. So what you get here, this is carbon number 1, this is carbon number 4. This is carbon number 1, this is carbon number 4. So in starch, you're going to get what's called alpha 1,4 linkage. So that means that the hydroxyl group off of the alpha hydroxyl group off of carbon number 1 and the alpha off of number 4 will, excuse me, can't even do my reactions correctly. So let me clean that up slightly, because I had my OHs kind of drawn funky. So I'll try that again. and we'll put OH in this direction. So we're going to get water removed, condensation or dehydration synthesis, and a connection there. And this would continue in both directions. That's starch, an alpha 1,4 linkage. It's a food source and it's a food storage or energy storage in plants. Human beings can digest this. Now, cellulose, on the other hand, is beta 1,4. So I'm sure you can figure this out, so I'll do my best to do it quickly for you. So there's the OH there. Okay, and here's the OH here. Now, it really does not matter here. I'm going to draw the... no, I won't do that. Notice that this alpha, on carbon number 1, this is in a beta linkage. And so what you're going to get is this is going to leave with H2O coming off, and the new bond between this oxygen and that carbon, basically, that's the beta 1,4 linkage. It's beta from here. Now I know this is rather sloppy, but what you're required to understand is starch is alpha 1,4, cellulose is beta 1,4. Human beings do not have an enzyme to digest beta 1,4 linkages. We do have enzymes to digest alpha 1,4, so we starch, potatoes, corn, primarily starch, a lot of breads, carbohydrates like starch. However, beta 1,4 would be like in the whole wheat. There's a lot of fiber, or foods that have, if you eat celery stalks, the fibrous portions of that, your body cannot digest them. The skin of corn kernels, cellulose, again, very fibrous, and the high fiber diet is very important. It is important that you understand that, because that is one of the IB points. You do need to have a diet high in fiber, because it prevents quite a few diseases. Specifically, for a possible 1 mark score, check that point on option B, and you'll see some things that dietary fiber takes care of. And also for B point 3.6, we'll talk about dietary fiber, RE in the European system, ER in the American system. I think that's all I'm going to go ahead and talk about. I guess I'll also tell you a few side notes. Human beings store sugar in a form of glycogen. Glycogen is another form of alpha linkage. However, it's not only alpha 1,4 like starch, it also has alpha 1,6. So I think you can reason out in a general sense what that is. Glycogen is typically stored in the liver and the muscles. And sugars play an important role in biological systems. They are the precursors for quite a few things. So some of the functions you need to understand about carbohydrates are that they provide energy. Even when we store fats, they are broken down and converted into sugars, which our body can convert into energy fairly quickly. The previously stated liver and muscle storage of glycogen, and also they are precursors for nucleotides, nucleic acids more specifically, and they also play a role in the synthesis of proteins. So I'm going to go ahead and stop there so I can edit this video to include carbohydrates. Again, if you refer to the copies I made, the scans I made of the study guide, probably called standard level or SL carbohydrates or option B or something. There's some good pictures there, and always refer to your guide and this video. So we'll come back with lipids.